Welcome everyone to today's webinar, using ultra-high resolution aerial imagery and LiDAR data to empower 3D city modeling and urban planning. My name is Catherine Ryan. I'm the head of marketing here at Skyline, and I am so excited to be here today with representatives of IGI Systems and Kavel 10. Before we get started, there's some quick housekeeping points. We're aiming for about 45 minutes of content, as well as some time for questions at the end. Please submit questions using the questions area on your GoToWebinar dashboard, and our presenters will be happy to answer them at the end or during their presentations as appropriate. This webinar is being recorded, and everyone who registered will receive a link to a recording via email later today, as well as a PDF of all slides presented. With me today from IGI Systems are Valerio Gulli, Senior Business Development Manager, and Dr. Jens Kramer, R&D Director. From Kavel 10, we have Data Specialist Ewald van der Kruisen. And from our team at Skyline, we have Jim Michaels, U.S. Sales and Business Development, and Itai Ben Schechter, the Vice President of Imaging Solutions and Services. Welcome, gentlemen, and thank you so much for being here today. I'm going to go ahead and turn it over to Jim, who's going to moderate today's webinar, and I will see you all at the end.
Thanks, Catherine. So the first thing I wanted to do, just to get everybody awake, if you're in the US, it's the morning, but we have some polls today. These are mostly just to help us understand some of your knowledge levels and interests, and it will help contour some of the demos. So if you can look in the poll section of your webinar, here's the first question, and I'm gonna boot that right now. So have you used products from any of the companies that are here today? And you can pick more than one. And this just helps us know what information to give you throughout the presentation today. And I'll give it another second or two. Just about everyone has voted. And we're going to close this. So it looks like we have a bit of the attendees today have used some Skyline software. It makes me happy. A little bit have worked with Kavel 10 and IGI Systems, and we've got a little less than half that haven't yet. So I appreciate you guys being here today, and looking forward to giving you some great information. So why are we here today? Well, it's because we got three great companies that all work together in the three different fashions of a project. IGI has one of the best sensors in the business. It's a state-of-the-art airborne sensor that collects great imagery that can be used for highly accurate and very high resolution 2D and 3D products. Look here, this is just one of the images coming from the sensor. One of the big value adds of IGI is they have a 3-in-1 sensor. So while the plane is flying in one pass, you're getting nadir imagery, oblique imagery, and LiDAR in a single flight. For those out there that don't know, nadir imagery is when you're looking straight down from the plane. Oblique imagery is when you're looking out at the distance at an angle. And LiDAR is a very huge laser rangefinder. So it shoots lots of little lasers at buildings in the ground, and it bounces back and helps create a model that way. The oblique imagery is great for getting side views of buildings to really see how many stories, what type of structures there are. And the nadir makes a really great mapping product. So again, three systems all in one to get us the best data possible to use. Skyline is a software company. We've been around a while. We have partners in countries all over the world. Our job is creating data from these imagery. So we create very high quality 3-dimensional models. We create 2D true orthos. We create surface models. And we give you robust analytic tools for design, measurements, condition assessment. And we work across the board: disaster relief, military, planning and design, and of course, surveying and mapping. So we try to give you the platform to utilize all of the imagery to either create your own products or use products that others create for you. And Kavel 10 is a company that a lot of people are a little unsure about diving into this whole process, themselves. People can be a little intimidated from collection to producing results to working with them. So Kavel 10 is a company that gives you that end-to-end solution. So they fly, they own IGI sensors, they fly for you, they process the data, and then they deliver your end products. So in case there's people out there that want to dip their toes into this world of digital twin mapping and really getting analytics out of their city data, there are some companies out there, and Kavel 10 is one of the best. They're based in the Netherlands, and I will let Ewood talk about that in a minute. So again, the reason everybody's here, we'd like to show you how all these three companies work together to create these ultra realistic 3D digital twins and 2D products, orthos and DSMs of their cities. And this is just quickly some of the things you're going to see today. This is imagery taken from Kavel 10 with the IGI sensor and processed in Skyline. So we have 2D orthos, very high resolution, easily measurable. We have 3D models that were created from that. We have our digital surface models, and we're showing some of the analytics you can do with classifications and building footprints, and you can work in a GIS system. So I got one more poll for everybody, just making sure everyone's still with me here. Just cue this guy up. So do you currently use or collect aerial imagery yourself for projects? We got about half voted. Give it a few more seconds here. Okay, we got about 75% voted, so I will close this and we can share the results. So right now, a small amount of people collect, quite a bit use, and then even more do both. So we're definitely in the right spot because, IGI has the sensor that you can look at. Skyline will help you process it if you need the right software and the right tools. And Kavel 10 is here in case you want someone else to collect your data. And we do have some that are looking to soon, so you can take a look at the end-to-end workflow. So I appreciate everyone's feedback. Now I'm going to turn it over to Ewood, and he's one of the members of Kavel 10, and I'm going to let him talk through what they do and the end-to-end solution they provide.
Yeah, thanks, Jim. Yeah, I'm Ewood from Kavel 10, as Jim introduced me. Good morning to the people in the US, good afternoon to the people in Europe, and good day to all other attendees. So you already got a quick introduction about Kavel 10. So we're based in the northern of Netherlands. So we are a quite small and young company. And what we actually do, we bring all those new and innovative techniques together and make it just work for you, for the end customer to use those products. So basically, we own two aircrafts. So those are Tecnam aircrafts from Italy. And why we choose those aircrafts, let me see if I can go to the next slide. Yes, this works good. So these aircrafts, they're very efficient. They're new. So we are also using not only latest and newest sensor technology or software technology, but also the latest and newest aircrafts available on the market. So we have a very efficient fuel consumption and low CO2 emission. But what is the main benefit of using these aircrafts for our products or 3D meshes which we create is that we can fly at a very low altitude, and we can fly also very slow. So in that way, we can capture a huge amount of images, which improves the quality of the mesh, and we can also fly at very high resolution, up to 2 centimeter GSD. So that means like 1 pixel projected on the ground will measure 2 centimeter. So we own basically 3 airborne sensors. So they're all IGI, as you can see. So we've been working with IGI for, I think, almost 4 years now. It all started with our Pentacam. So that's also the main sensor which is being used for creating those awesome 3D digital twins. So next to that, we have a LiDAR scanner. A little bit more about that in my next slide. And we also have like a large format camera since this year. So it's a 450 megapixel camera from IGI. So what is inside those sensors? The Pentacam consists of phase 1 sensors. So we have 5 times 100 megapixel. As Jim already told you guys, so we have 4 oblique images. They are looking under a 45 degree angle, and then 1 down looking nadir camera. So we have very high quality lenses, and we have these phase 1 sensors are famous to have very high dynamic range. So we are very flexible, and then time frame wise when we can capture those data. And we have this combined with a light mapper, so that makes it quite unique. Our aircraft, they have 2 hatches, one in the front, one in the back, and we can install 2 sensors in one time, and then we can combine all this data in one capturing. So you can see that in the green square. Beside that, we also have a large format camera. I just wanted to mention that we have it, but it's not really used for this 3D digital twins creation. So last but not least, we also do have a mobile mapping system. You might ask, why do you mention this? It is actually possible in Skyline software to also merge mobile mapping data, so LiDAR, but also panoramic 360-degree imagery. So that's also one of the latest developments we're looking into to improve that, and to improve our meshes on street level. So as I mentioned before, we combine all sensors, so we call this sensor fusion technique. What is the benefit of this? Of course, costs. We can combine this. We only have to do 1 single flight, and you get like the best possible input data for your 3D meshes. So we have the newest Regal LiDAR scanner, so we get a very high point density. So we can also, with our LiDAR, see under trees, and we can improve the mesh model a lot with our LiDAR sensor. So a small overview of what we capture. So it is in Dutch, but it's not so difficult to translate, I guess. So we, of course, capture oblique images. We can create ortho or nadir-looking imagery. We can also, of course, make ortho photo mosaics. We capture LiDAR. We capture all those kind of data, and we are actually helping the customer to reach their end goal. So we're not just delivering an image or a LiDAR data set. No, we are really going to work together with the customer very close and see how this data can benefit for them to satisfy the customer. So, and that's also where Skyline came in. So actually, I will show you in my next slides. It all started with a pilot project in Rotterdam, and yeah, we got in touch with Skyline, and our customer was looking into digital twins. It was 2 years ago in the meantime. So maybe a little bit more first about digital twins. So this is like the magic cycle of 3D digital twins, what we call it here. So it is actually a kind of cycle. Of course, you need to start with something, and the first thing to create a digital twin is like capturing good data, of course. So therefore, we are here with Kavel 10, and you can see the cycle. Of course, Skyline, they can assist with processing. They can also assist with hosting with the Terra Explorer web viewer. And after that, there's Kavel 10 again. which can help the customer to manage this data, to keep the database, the 3D mesh up to date, to help extracting data from that and effectively do something with these digital twins, because that is, I guess, one of the main reasons a lot of people are still not using digital twins, because they are asking themselves, why should we use it? I will show you some use cases later. But yeah, this is the cycle, and it's important, of course, to keep it up to date. So once you've made your initial model of 3D digital twin, you can, of course, update it with new data every year or every few months. So a few of our projects. This one, I think most people already seen it on LinkedIn, passing by. So we've been flying in London City last years. I will quickly tell you some technical stuff, like on what altitude is it flown, and then after this I will show you or tell about the use case of the model. So this is the Tower Bridge, of course, in the center of the London City. So it was flown at around 2,000 feet, 600, 700 meter. We got a GSD, ground sampling distance of 5 centimeter. The overlap in the front was 80% and side overlap 65%. So that's a little bit at the low side for high res models, but it's still looking pretty nice, I think. And that's, of course, thanks to the perfect sensor we have, and this is the very good software of Skyline. Also very important for this one, maybe, this screenshot is not zoomed in, but we have LiDAR. We also captured LiDAR, of course, for the data set, and that also helps a lot to reconstruct very small objects, like we have on the Tower Bridge. We have those wires. So yeah, if you would zoom in on the model, you would see that these are modeled pretty well. Also, the small towers of the bridge itself. So what is it used for? We've done several projects in London in the meantime. So main goals are for city planning. Also, it is used a lot for real estate. So London, of course, it has a lot of very high buildings, and it is a city which develops very fast. So they're placing a lot of new buildings, and therefore they're using our data to see how new buildings would impact the area of the city. So yeah, and of course also for cultural heritage, for example, the Tower Bridge, which is a cultural monument in London. One of our next most recent project, actually, it was Groningen City. It's nearby. Actually, we're very proud to do this because it's also the city where our aircrafts are at the airport. So the final results still need to be announced of this, but it will be very amazing. First of all, I would like to mention that this is not just an oblique image or some photoshopped thing, except for the logos which were added, but this is actually a screenshot of the 3D mesh. So you can almost not see any artifacts or bad things. It was flown very low, 1,000 feet. We got a resolution of 2 centimeter. We combined that with LiDAR of 400 points per square meter, so that's really amazing. We also have a lot of points on the walls of all buildings, and we went for 80-80 overlap. So this is really the highest possible accuracy you could get, in my opinion, from fixed-wing aircraft capturing this data. So the goal of this, quite a lot of cities in the Netherlands, there goes very straight ahead on developments and 3D digital twins. Rotterdam, the city of Rotterdam, they kicked it off a few years ago, and now you see in the Netherlands the trend that a lot of cities and municipalities are following them. So actually what they want to do is they want to go from their 2D GIS system, where they keep all track of all their information from the whole city. They want to go to a 3D system. So we help them in those process to transfer from 2D to 3D. We do it with partners, so IGI and Skyline are two of them, but we also have some other partners. So basically, they have a lot of applications. The city of Groningen of this. Of course, it's used for city planning, but also cadastral information. And it's also very object oriented. So people know a mesh often as like one complete triangulated 3D mesh. But actually we will also classify objects in this 3D mesh, like the building you can see in the image, and in the middle it will be like clickable, and we can add attributes to that one building. For example, the same as for trees, lamp poles, whatever you want. So this is one more screenshot. Again, this is a screenshot of a 3D mesh. It's not an oblique image. So you can see how high the quality is. Rotterdam City, as mentioned before, we were very proud to be part of this because I think definitely in Europe it is a famous project. It has been started three or almost 4 years ago, I think. And we were honored to capture some data for the city of Rotterdam. So it was captured at 2,000 feet, the same as the Tower Bridge. Actually, those specifications are almost identical to the Tower Bridge, except we had a little bit more site overlap here. So I will straight jump ahead to this one more screenshot, to some applications of this Rotterdam City where you can really see it. So here in this case, we have a 3D model. So we have the mesh in there, but also a LOD. So it's a modeled, a simplified 3D model, let's say. So, and in the background there, you can see that building in red, which I clicked on. And you can see a lot of attributes which is hanging on that element, on that building. So that is what I mean with the transformation to 3D GIS. So instead of looking in your ArcGIS or QGIS system or any other GIS system on a flat object and clicking it, you can now see everything in 3D. And it goes very far for Rotterdam, at least. They, for example, also modeled all their trees based on our data. So they keep track of the, when was the tree planted, what is the diameter, what is the height, what kind of tree is it, all those things. The same is for lamp poles. As you see here, there are small objects, but in the background of the image, you can see all the lamp poles. And again, there's they keep track of a lot of attributes from this object. So that's a few examples of why or what our data can be used for. And then last but not least, the mesh is a little bit less nice. I can be honest in that, but that's because of the choice of the customer. Of course, a good quality mesh goes with high flying altitudes, low flying altitudes, and high overlap. And of course, that costs flying time, so also money. This mesh, it has been used by an engineering company in the Netherlands. And what they actually did, they cut out the old streets and the 3D mesh, and they pasted in a new design. So they used it to present to all the people living there in the neighborhood. They had like a meeting and showing them like, hey, this is how it's gonna look within a few months, and this is what we're gonna change on the streets in the area. And in this way, the people living there can recognize their house and see what will happen exactly actually in front of their house. So this was my last slide. Again, I hope you can clearly see what we do. We combine all those data, and I think I will now give back the presentation to Jim.
Thank you, Ewood. We did have one quick question for Groningen. I can't say this one, but Groningen. Yes. It looks amazing flying it, 1,000 feet. What was the speed of the aircraft and time interval for the 80% overlap?
I cannot exactly tell you on a tenth of a second, but it was 19 knots, I think, 19 or 100 knots. I think the stall speed of the Tecnam aircraft is 80 knots, so a little bit above that. And 80% forward overlap, that would mean around 1 second time interval. This phase 1 sensors, I think IGI will also mention it later, they can go to 0.8 or even 0.7 seconds time interval between 2 images.
Perfect. Well, thank you, and thank you for describing all the work you've done. I've got to travel to the Netherlands, and they do have some of the nicest streets I've ever walked and biked on. So the design aspects are really important.
Exactly.
One last question: does Kavel 10 also deliver digital twins of other cities in the Netherlands?
Yeah, of course, I did not really mention, but yeah, we're located in the Netherlands, but we have aircraft, so of course we can fly other cities. We have some data on the shelf, but we might also need to capture it. It depends. But of course, also as you saw, the London data, we're also busy and outside of Netherlands, the Munster data which we captured. So yeah, we are actually active in the whole of Europe. Yeah.
Okay, well, thank you, Uwood. So I wanted to move on. We had another quick poll just to get some more information from everybody, and I see everybody's already answering this. I'll stop it in 1 second here, and we can look at the results. And we're really looking for what types of data do you currently use? And so we have a significant amount of people that do use all of the above. And again, that makes me really happy from Skyline that you're working in 2D, 3D, and LiDAR, because each one of them bring different value into a project, and you can get a lot of intelligence and a lot of information from all the different products here. So just some fun, little pictures. Again, just going through how great the sensor is and what we can do with the state-of-the-art software nowadays. We have some 3D models here that, a lot of people can't even tell that they're 3D models, but this is a model, not an image. And same thing with this one, another model. And you can tell a little bit by the trees, because very fine leaves are hard to model, but the buildings do get a, true digital twin. So I did want to take a quick minute to introduce Skyline, and Itai is going to give you a live demo, so I don't want to take away Itai's thunder here. But for those that don't know Skyline, we create very robust state-of-the-art software that lets you create, edit, analyze, and serve 2 and 3D data. So we are the ones that build these 3D models and true orthos, DSM, DTMs, and even simulated point clouds. And we have the software that creates, we have the software that lets you analyze and edit. And then we do have services, cloud services, where you can serve these products out to all your customers or all your teammates, either into desktop or web applications. PhotoMesh is our product that creates all these models. So you can create these models from aerial imagery, drone imagery, pretty much any imagery out there, as long as it's framed. Obviously, when you use a really great sensor like IGI that's very high resolution and gives you both that nadir and oblique imagery, we can create the most optimum, best looking models. And these models aren't just pretty pictures. These models can be measured, down to sub-inches. You can do a ton of analytics on them. Something we really specialize in is edge detection. So our models look very clean around the edges. And we support almost every camera system and almost every output. So we don't want to limit you to Skyline software to consume this data. So our format is a 3D ML format. The benefit of that format is it gives you a lot of pyramiding. It gives you really fast performance at all visual scales. But we do work with OBJ, we work with Esri formats, Cesium. So just want you to know that we try to give you the data to work with however you need. And these are just some of the things we've done with photo mesh, some of the 3D models out there. And I did want to show, I just want to show some comparisons, or a quick comparison between some other packages out there. We do consider ourselves the professional grade modeling company. So that edge detection and the patents we have on that edge detection is, really key when looking at condition assessment for structures. So that's another workflow where a lot of people are using digital twins, is to do condition assessment, overall tax assessment, really understanding what they have for planning. So Terra Explorer is our desktop and web-based software that lets you do all the analytics with these imagery and models. And as Ewood showed, you can add in your own textures, whether it's fires or cars or planning. You can start to do your own stuff inside there. Terra Builder lets you build all of your surface models, your DSMs, your DTMs. And we have our Globe server, which is what lets you take all these models and analytics that you do and serve them out to, again, all of your potential customers or your potential teammates. And it lets you, interface with the web. And we have our Terra Explorer for web as well that Itai is going to show you, that just lets you consume all this stuff in a web application. So it makes it faster and easier to share without people having to have desktop computers. And we did try to put a lot of the analytics in the Terra Explorer for web. So again, you can do a lot of the main types of things that people typically do with 3D, from profiling, measuring, view shed analysis. Measuring volumes is key. Understanding in construction what's been moved, what hasn't been moved, change detection. All that stuff can be done in the web version, along with more robust in the desktop. So one more quick poll here. What workflows are you most interested in or currently working on? As I see everyone starting to answer, this will really help Itai here in a second to give you some live demos. And while you're taking a poll, there was one quick question. What is the starting point of the data input into Skyline? Is pre-processing done in Skyline, or is it post-processing? Skyline typically will take the fairly raw data from the sensors. So they do need to be geolocated, but Skyline will typically take in the raw data from the sensors, and it does all of the processing, all of the matching, tie point creations, and then it builds your 2 and 3D products. And Itai can elaborate on that a little bit more. Okay, I'm going to close our poll and just share that really quickly. So we do have a lot of people doing mapping and measuring, which I like to see. My tech background loves measurement and gaining information from imagery products. We do have a little bit in condition assessment, and that's a growing field for 3D products, is getting that condition assessment. And then we definitely have some construction and planning and design in there. So I like to see that, we do have a wide range of audience here, Itai, so we can touch on a few of these topics. Itai, if you can quickly look at the questions, there is 2 more advanced questions for Skyline that maybe you can answer while you're doing your demo here.
Yes, yeah, I'll address a couple of these questions, no problem.
Thank you. And so I'd like to turn it over to Itai to, show you live. And again, the key part here is, we're using all of this data is IGI, from the IGI sensor. It was all flown by Kavel 10. And want to show you guys what you can really do with these products. So Itai, I will turn it over to you.
No problem. So as you can see on my screen, I'm going to go through a quick demonstration of the London data set from Kavel. and show you the integration of the IGI system and imagery along with the LiDAR data set that was collected. So what you're seeing here is the photo mesh interface. You can see the location of the cameras. And just to address one of the questions as we're going through this, we do perform aerial triangulation, matching, bundle adjustment, incorporating control points. We don't address IMU misalignment or doing the lever arm correction. Those are things that get done as part of the bundle adjustment, but in terms of getting to a corrected aerial GPS or input exterior orientation, that's usually done in the camera post-processing and the image post-processing after the flight. We do, if there is control, have very advanced and robust capabilities to minimize any errors and achieve a very high accuracy result, which we'll review as well. So we can see over here, we're able to really quickly generate a coverage map, and we can see the oblique images coming in from the side, nadir images, and the four directional coverage of the obliques. And the green means 5 image coverage. So one of the things that we could then do is I'll turn on the LiDAR and we can see how it can integrate into the terrain. So this is the LiDAR data. And one of the things that's possible in order to verify accuracy, either using checkpoints or control points, is you see I could visualize the LiDAR intensity, sample a spot on the ground, and then we can see how many of the images integrate into that point and then are able to triangulate with extremely low residual. So this is our control point measurement interface. And you can see the feature that was measured, and we can see the different collections it was captured from. So you see the nadir, the right-looking images, the different obliques, and they all correlate, pretty much to the sub-pixel level of the measured feature. They're asking, is there tight integration of image and LiDAR georeferencing common bundle, including image and LiDAR strip adjustment? So we don't do the strip adjustment for the LiDAR. We work with different partners that work on the LiDAR processing side. The LiDAR usually is processed for its highest accuracy before it's integrated into PhotoMesh, but we have the ability to then match up and cross-optimize the image-based point cloud and the LiDAR-based point cloud. So one of the things that we'll look at into part of the processing is when we process the full 3D data, this is the image-based point cloud. So this is the point cloud that was produced from the integration of all the oblique images. And you can see the LiDAR data, and they align very well together. So it's able to really create a sort of where the LiDAR fills in. You can see over here on the trees or some of the thin poles, it's able to fill in also data underneath the trees through the multiple returns. So we do have on the 3D reconstruction side, optimizing the integration and the surface creation. So then when we create the surface of the data, this is the surface model, and then the textured model on a single tile. And one of the things to stress here and emphasize is that Skyline's scalable technology is able to split the project up into various tiles. Depending on the size of the project, the tiles get calculated automatically. And then every single one of the tile can be processed on a separate computer. So you can scale up to really an unlimited amount of computers in order to run very large projects. And we'll look at one of those projects where we processed the entire city of Berlin, over 1,000 square kilometers in 3D. So once all these textured models are produced on a tile basis, we produce the full 3D mesh model. And like Iwood was explaining, the integration of the LiDAR, you can see the quality of the bridge suspension and its ability to correlate very thin features on top of the tower, such as the flags, these tops of these pirouettes. And additionally, you could see the quality of the trees benefiting from the LiDAR and the canopy penetration. So you can see how it's able to correlate data underneath dense canopy. And in areas with a lot of trees, you still get all of the data down on the ground. So that's very impressive. The other benefit of the LiDAR is in very dense neighborhoods where the buildings are very close together, like over here. You can see the LiDAR helps get down all the way to the street level and incorporate texture, even though this is an extremely dense neighborhood and in between very close buildings. So you can see how the integration of the LiDAR and the imagery is able to create an optimal output, as well as be able to reach sort of hard to map places that might be a lot more difficult to see into if it did not include the LiDAR and good overlap imagery and obliques and nadirs. So these are some of the examples of the quality that's possible to achieve with the IGI system and Kavel 10's great data collection. So we'll jump over a bit into what do you do with the 3D data. So you produce the 3D data, and then you could load it into Terra Explorer. Terra Explorer is our desktop application. We also have the web application for it that I will jump into. So we can see over here, we have the ability to visualize the images. This is the photo inspector, so I can click on a spot and then load the image and the different images that were used to map the 3D model in that area and sort of move between them. And there's also the ability to do really any type of measurement that you want, whether it's aerial measurement, vertical, horizontal, 3D measurement of 3D plane surfaces. One of the things that you're noticing as I'm moving around is the performance. So the software PhotoMesh produces the 3D data with built-in pyramids, and we can also create other formats that have built-in pyramids. And if you look at the display, we can see how the triangles produce the pyramids based on the screen view, and they can then cache it in. You can see how it's loading in the highest resolution triangles as I'm zooming in. And as I'm zooming out, it could lower the triangle count so that you can have very great performance. You can see right now this rooftop is composed maybe of 4, 5, 6 triangles. And as I zoom in, it could literally be thousands, if not more. So that's some of the advantages of producing large 3D data sets. Additionally, the data can have incorporated classification. So if you have GIS data such as footprints, you can see this is the footprint data for this area, just a 2D footprint, but it could also have a 3D component such as the height. That could be embedded dynamically into the mesh so that I could then colorize the mesh or query it based on attributes. You see, these are the different buildings, and you can also create sort of your own legend based on how you want to colorize it. And then you can also query it. So just click on any building, and you can get all the attribute information for it, or just query it directly using spatial query. So I can just mark all of the areas that are within a certain square and view the attribute table. So the 3D is more than just a visual tool. The 3D ML can incorporate attribution, becomes truly a smart mesh, what we like to refer to it as. Some of the other tools that are possible is we have the ability to then isolate a certain building. So let's say if you're in a very dense city area and you want to only want to look at a certain building because it's being covered by other buildings around it. So you could then clip the box and let me select that box. There it is.
Itai, we have about 1 more minute for demos. So right after this, if you want to show the web interface, and then we're going to move to IGI. And we'll answer some of the questions at the end. I know there was quite a few questions. We'll try to answer at the end if we have time. If not, we're more than happy to set up another meeting to discuss some of the questions on what we can do with the software.
Okay, so just real quickly, I'll go over Berlin. This is the large data set that we processed that was composed of about 46,000 images from the IGI Urban Mapper, a total of about 7,000 gigapixels. And you can see the control point accuracy, pretty much sub 2 centimeter average. And we processed it in about 2 days using our production facilities. So just a quick idea of very large 3D ML, over 1,000 square kilometers, and how well it performs in the tool. And real quickly, I'll also show the web interface, and we can move on to IGI. So this is the project we were looking at, Münster, in our Terra Explorer for web, along with all the different analytic capabilities. You can see the viewshed analysis, volume measurement. So this is all possible to do on a web base. You can see how quickly it streams from the Skyline Globe server. So yeah, that's about it for my demo. Jim, you can take it back.
Thank you, Itai. I think you have to stop sharing so I can reshare.
Hold on. We'll remake you the presenter. There you go.
Thank you. Okay. So again, everything you've seen thus far has been, using IGI sensors to get these really high quality data sets to work inside a Skyline and have real world applications. And again, I know a lot of you guys answered the polls. We couldn't hit on every type of topic, but we're more than happy to have follow-up meetings. I do want to turn it over to IGI with Valerio and Jens, because I want them to tell you why they have one of the best sensors in the world and the benefits that you get if you utilize the IGI sensor. So Valerio, I'd like to turn it over to you.
Hi, Jim. Thanks a lot. And thank you, everyone, really for following. We have been very amazed with the number of the subscribed, which is more than 300 people from all around the world. And we are very happy to be here together with our partner Skyline and to see in particular Kavel 10, this truly amazing imagery. And the idea now is to really go through the technology and the science behind such unique airborne sensor, also mobile system. It's not so easy for me to go through a few slides and to pass later for technical specification to my colleague Jens, which is the director of R&D at IGI. So we're a family company based in Germany. We have 45 years of driving innovation to deliver engineering excellence. This is what we do. We have a very diverse portfolio. Today, we're focusing on our mobile system and airborne system in particular, which are operated by Kavel 10. Just focusing on the Urban Mapper 2, which is exactly what you've been seeing in Münster. We have also LiDAR system, and just for you, we've been integrating this LiDAR sort of hybrid, it's called now in the market technology, for about 15 years. So it's something not very new for us and for our client. Let me just go through the next slide. Just showing you another image from the city of Münster, which was flown by Kavel 10 with the new Urban Mapper 2. Is a very unique sensor collecting 2 gigapixels per second with superior image quality and resolution. You can go down to 2 centimeters, flying from 800 meters. Of course, you can also capture a different resolution, and Jens will show you a table just for some reference. It's a very special sensor. We call it a special mission sensor with 150 millimeter lens. So can be operated from high flight altitude. is a professional camera, which means it's delivering photogrammetry grade, oblique, and nadir imagery. You can also enable the collection of just nadir frame, and you have the largest footprint for the nadir with 450 megapixels. It's a very fast camera. It's dealing very well also with challenging lighting condition, as you can see from the mesh. You can go through the vegetation. You can see very detailed facades information from the building. You can even see people. So very good dynamic range, working really well also with moving objects. And it's a very, very impressive data set, which, by the way, is open, and we're very happy to share. So feel free to approach us or Skyline to get your demo. So what we like to say is a very efficient, productive, and fast sensor. A setting definitely is shaping a new era for 3D city modeling. And what we like to say, because we've been supporting our clients like Kavel 10 and AeroWest, which, by the way, AeroWest is the company that has been flying the city of Berlin, which was just shown before by Itai. Very impressive data set. So you can do massive also collection for city or even countrywide mapping for high resolution, also for governative projects with different GSD. I will quickly go to the next slide. It's just a collection of imagery. There is no retouching, it's just what you get directly from the sensor. Again, is like you will see directly, and I think the demo was a very good opportunity to see what you can produce with this type of imagery. So superior image quality, accuracy, and much resolution will deliver the digital twin that we have been seeing before of cities. We also have government clients and clients working in the military for mission critical projects. And this is really, before going to the technical specification, I want to show you this antenna. It's just 5 meters in height and less than a meter in width. You can see even the people walking in the street clearly depicting also the cars. So it's a very impressive resolution. Sometime we see also a great demand from the market, and we really like to work like with Skyline in particular, because it's highlighting what you can do with this type of imagery. But it's also a pleasure to see a company like Kavel 10 growing from a family company in Netherlands, also growing to Belgium and flying city like London. And this picture is really linking with the London. As you can see, this was exactly the scene that was shown by Itai before. Sometimes I get questioned by our clients, how do you deal with the shadows, or how you can perform in challenging lighting conditions. As you can see here, you have very good quality. Oh, okay, just going back. Yes. So further. Okay, that's perfect. So you can clearly see the colors and all the information in the facades. So it's a very special configuration with LiDAR, and we will show more later. So feel free to approach us. I had also another slide, but it's not here completely fine. I would like to start to introduce Jens, but before going here, yet just an overview coming from the nadir to the oblique. So overall, what you get with an IGI sensor is superior image quality, unmatched accuracy, and resolution is really up to the client. So we have clients like Kavel 10 going for 2 centimeter, also going to 5 centimeter GSD, 7.5. It's really up to the client to decide what to do. Well, just a very brief overview on my hand. I would like to now have Jens taking care of the science behind this sensor, and in particular focusing on what we've been showing today during this demo.
Okay, thanks, Valerio. So there's not too much science in the moment, but at least I can try to explain a bit how these sensors work, or how they are built. So the sensors that have been used for the projects that you saw up to now. Of course, in this webinar, I cannot really go into the technical details, but I would like to touch 2 technical topics a bit. And this is at first how the camera is built, so how the camera modules are put together, and then also how the images are stitched together to make a really large nadir footprint. So in the examples that you saw, there were always, we would call it 2-in-1 sensors used. So sensors where you have nadir looking camera was explained before, and also cameras that give you an oblique view. What you see here as examples is on the left side a system that we have built already some time ago, and this is already what Iwood has been explaining. They are using two separate sensors, one for LiDAR and one for the two-in-one. So this also could be integrated into one sensor if you would only have one camera hole in your aircraft. And then in the middle, we have the Penta Digicam as used by Kavel 10, so 5 cameras together. And on the right side, we have the UrbanMapper, and the UrbanMapper is the one that I really would like to show now a bit more in detail, because it's really special. The UrbanMapper is the development that we started after we have been operating these Pentacams for quite a while. And so there we sat together with developers of photogrammetry software, and we have tried to find out what should be improved to make these systems even more productive. So we came out in the end with the idea, or with the knowledge, that it was necessary to get a really significantly larger nadir footprint, not only the typical size of the medium format cameras. So what we did in the end is that we combined several nadir-looking or nearly nadir-looking medium format cameras, and then to develop a stitching software that would create a really large nadir footprint. So in the end, the UrbanMapper is really optimized for the automatic production of 3D GIS data, but it's also possible to create all the standard mapping products with it. So in the end, what you have, if you use it, you really have a very large nadir footprint. You have a high image repetition rate. This is, of course, necessary to create these high overlaps. What you also need is the possibility to work with short exposure times, because if you look at the forward motion for the oblique images, you in general cannot really use the normal FMC technique, so you have to expose quite quickly. For the same reason, you would need a high sensitivity. And of course, for the matching, it is always helpful and always necessary to have a high dynamic range for optimal matching results. In the next slide, you see that we are integrating different kind of camera modules at IGI in general. So we integrate sensors from different manufacturers, like from Hasselblad, from FLIR, from Phase 1. This enables us to really provide sensors for different spectral ranges, and also with a very wide range of lens options, ranging from a few millimeter focal lengths up to 300 millimeter focal length lenses. Especially for the UrbanMapper, we are integrating the Phase 1 IXM RS150 because it has 150 megapixel CMOS sensor with a high image repetition rate of about half a second. It has a very high dynamic range, 38 decibel, and it can expose very quickly. In the end, what makes this Digicam or an UrbanMapper, of course, is a careful selection, careful focusing, adjustment, and calibration that we do at IGI. So how does the UrbanMapper look like? Here in the next slide, you can see on the right side how the sensor itself looks like, with the sensor part here on the bottom and the computer part on top, and also in the other image, how the system looks like when it's operated in the GSM mount in the aircraft. So as mentioned, it's a two-in-one aerial camera system. We have a large format camera with near module for the nadir view. We have 4 oblique views. It is all modular, so that's quite interesting. For example, when Iwood was telling that they are now operating 450 megapixel Digicam. So this is, let's say, the nadir view of the UrbanMapper 2. So they would always be able to upgrade their system with oblique camera modules, just in case they want to upgrade the system to this capability. There are also different lens options available. And what is the main topic is really what we get out is a very large native view, in this case with more than 34,000 pixels across flight direction. So the data set of Münster that you have seen has been flown with a special version of this UrbanMapper 2, a version with 150 millimeter focal length in the native view. So with 150 millimeter lenses, we can reach 2 centimeter ground sample distance at 800 meters flying height, or let's say 5 centimeters GSD at 2000 meters flying height. It has been specially built for a customer who is operating in in Eastern Europe, and they had the need that they were not allowed to fly below a certain level, a certain flight level over large cities. That they still wanted to keep a high GSD, and with the 150 megapixel sensor, 150 millimeter lens, this is easily possible. In addition, what is quite nice is that you really get a very small building lean, especially if you go to very large buildings, so that you really can see nicely into all the urban canyons.
And Jens, we got about 1 more minute just to let you know.
Yeah, okay. So I had 6 minutes. So that's a bit surprising now, but I will try to just focus on the most important topic that I would like to show now at the end. So this was the UrbanMapper 2. Let me go to the next slide here. And this is, I would really like briefly to show how these images are stitched together, because we mentioned there are several camera modules involved. We have 4 modules here on the side for the obliques, and there are 3 modules in the middle. And these 3 modules are stitched together to a uniform image. And okay, maybe some of you have already seen these plots on the right side. So in the end, it shows that we can really stitch these 3 images together to one very homogeneous image that can be used absolutely as if it would have been captured by one single sensor. So I wouldn't like to go now into the details of the stitching. So anybody who is interested definitely can contact us, and we can go into the details here, of course, at any time. One last topic that I really would like to mention is that there has been some discussion about that this slight oblique angles of the left and right looking camera would create distortions or variations in the GSD of the sensor, and that this would give really problems for the processing. And I would just like to mention that this is a topic of the sensor, but it's not really a topic in the processing, because as you see in this image here, if we look at the 150 millimeter lenses, this is the deformation of the sensor on the ground and the stitched image. So in the end, if we create orthophotos with it, for example, with a 60% side overlap, and we just use the netto model of it, this variation in the GSD on the ground is just 1%. So in the end, it's not the, let's say, 10 centimeter that was planned, it's 10.1 centimeter. But doing this, we avoid all the problems that other sensors have if they shift the sensor and if they shift the sensor area into the corners of the lenses, of the lens circle of illumination. So maybe this was now a bit quick on this topic. But as I said, everybody who's interested can definitely contact us here, and we are happy to explain that. Okay, so I think I needn't read through the different topics, but they are included in the handout that has been created and that you can download now into the PDF. But I think I was able to show at least a part of what we are doing to really make these very nice projects possible. With this, I would give back the control to Jim.
Thank you, Jens. So I think, you've kind of seen the theme here today, using, again, high resolution, very accurate sensors in IGI, gets you to building some amazing 2D and 3D products for a wide range of workflows. And there are some great companies out there that will help you with your projects, consult, or even do them from start to finish for you. Here, I just wanted to leave everyone's contact. So again, we were trying to fit a lot of content into a short time here today, just to give everybody an idea. So please feel free to reach out to anyone and any of these emails to set up further meetings, more details. We can stay here for a few minutes and answer some questions. I know there was quite a few questions on here that we didn't get to. So we will unmute everyone and we can answer some, or we can set up follow-up meetings again to answer these questions. But I thank everyone, and a reminder, the handout section of the webinar, you can download today's presentation to read through more of the slides that we did have to gloss over. So feel free to download that handout from the webinar section. And Catherine, anything else you would like to add?
Well, thank you guys so much. That was fascinating, and I appreciate you staying on a little longer to answer some questions. Everyone who registered will receive an email with a link of the recording to this webinar, as well as links to the different companies, and a link to the PDF that is also in the handout section of your GoToWebinar dashboard. I can go ahead, I think, and mute all of the attendees if you want, Jim, or you guys can answer, or the organizers, what would you feel would work best? We've got about 100, 115 people still on.
Well, let's unmute everyone for the moment. Please, if you don't have questions, feel free to sign off or make sure that your computers are muted. And I'll try to touch on a few of the questions and just see if those gentlemen are or ladies are still here. And if not, we'll just do some follow-up.
Okay, I am trying to unmute everybody.